Lesson 30C, we are graphing linear equations, and you're going to explain the steps of how to graph linear functions. So start with some vocabulary. We have linear equation. Go ahead and fill in the blanks on your notes. It's an equation whose solutions form a straight line on a coordinate plane. And a linear function is a function whose graph is a straight line. Solution, an ordered pair that makes an equation with two variables a true statement. Write that on your notes, please. And then the first thing on your notes is this question. Is the ordered pair 1, 2 a solution to the following equation, to this equation? And what that's asking you is if you plug in the numbers 1 for x and 2 for y, because ordered pairs are all x, y, right? Will it be true? So let's do that. 1, where you see x, 2 equals 1 plus 1. Go ahead and is negation 2 negative, what's negative 6 minus 10? Is and 40, where you see y. Does 20 equal down everything that I do? So we have x as our input, and we're going to plug in that number to the rule, which is the equation here, and out will come the output. Now our x and y is going to make our ordered pair. So let's pick easy numbers like negative 1. For our input, and I'm plugging that into the rule. So go ahead and write this down. 4 times negative 1 minus 1 would be negative 4 minus 1, which is negative 5. So our ordered pair is negative 1, negative 5. Let's pick another easy number, like 0. So 4 times 0 minus 1 would be 0 minus 1. Which is negative 1. So our ordered pair is 0, negative 1. Another easy number we can plug in is 1, keeping our lives easy. 4 times 1 minus 1. What's 4 minus 1? What's our ordered pair going to be? Ordered pair. 1, 3. Very good. So now taking this, we're going to graph it on our coordinate plane here. We have negative 1 means to go sideways 1, and then down to negative 5. The first number is x, that's always side to side. Second number y is always up and down. Now we have 0, negative 1, so 0 and then down negative 1. And then sideways 3, up 1 and up 3. I know you don't have rulers, just do your best to draw a straight line through all of those points, and make sure you draw arrowheads at the ends of your line here. What this represents is a visual representation of all of the solutions for this equation. So just like we practiced in number 1, 2, and 3, is that ordered pair a solution? All of the ordered pairs on this line, I didn't have to pick 0, 1, and negative 1. I could have picked this one, I could have picked this one, this one, this one, this one, this one. There are so many dots on this line that it looks like a solid line. All of these dots on this line, not just the 3 that I picked, because I could have picked anything, right? These are all numbers that if I plug into this function, it will make a true statement. But if I pick something like this dot over here, if I plugged in negative 4 and 7 for my x and y, it's going to come out to be a false statement, because obviously it's not one of the answers, right? It's not on the line. Does that make sense? So the steps to graphing a linear equation is to do what we just did. Find at least 3 and then plot them on your graph. So let's do some of that practice here. Look at number 5. Their new linear function we're looking at here is now y equals 3x plus 1. So I'm going to keep it simple and plug in these easy numbers. Negative 1, 0, and 1. 3 times negative 1 plus 1. What's 3 times negative 1, Matt? What's 3 times negative 1, Matt? Negative 3. What's negative 3 plus 1? Negative 2. Please write that on your notes right now. What's our ordered pair? -1, -2. Let's plug in 0. 3 times 0 plus 1 would be 1. So our ordered pair is 0, 1. 3 times 1 plus 1 would be 4. So our ordered pair is 1, 4. Now we can graph this on our coordinate plane. -1 and then down 2, 0 to up 1, and over 1 up 4. Here's my line with arrowheads at the end to indicate that that line goes on forever in both directions, and every single dot on that line, even the ones that I didn't actually plot, is a solution to this equation. If you plugged it in, it would be a true statement. Okay? You'll see, starting from number 6, that our table no longer looks so complicated. I've simplified it to just be an XY table, because since we are choosing very easy numbers to plug in, you can do that in your head, right? So I'm not going to make you show all your work here. I'm plugging in -1, 0, and 1. Really easy numbers. And let's just do this in our head. 2 times x would be 2 times -1. What is 2 times -1? -2. What's -2 minus 3? So that's my y. And that is my ordered pair. -1, -5. They're right next to each other now. It's a lot easier for me to see. Plug in 0. What's 2 times 0? -3. -3. Plug in 1. What's 2 times 1? 2. 2 minus 3 is -1. So now these are my 3 plots that I can put on my graph. -1, -5, 1, 2, 3, 4, 5. 0, -3, 1, 2, 3, and 1, -1. This line represents every single solution that I can plug into this equation to make a true statement, meaning those are all solutions. Alrighty? Go ahead and do number 7 and 8 on your own. You can pick any number you want for x, but like I said, why pick really hard numbers to multiply when you can pick easy numbers like -1, 0, and 1. You can pick 27, you can pick -53, you can pick 4, but why? So here, I can do this in my head. What's negative times -1? +1. What's +1 plus 1? 2. There, I got my first point. What's negative times 0? 0. What's 0 plus 1? 1. Easy numbers. What's negative times 1? -1. What's -1 plus 1? 0. I have 3 really easy points to plot. So over -1, up 2. Over 0, up 1. Over 1, down 0. Here's my 3 dots. Here's my line with the arrows at the end. This line represents all the solutions that would make this equation true. Here's number 8. Pick really, really easy numbers, like these 3. -1 times -4. 4 minus 1. Okay, -4 times 0. -1. -4 times 1. -4 minus 1 is -5. There I have my 3 points. -1, 3. 0, -1. 1, -5. 1, 2, 3, 4, 5. Does your graph look like mine? Okay. Again, this line, this graph, represents all the solutions, all the points that you can possibly pick to plug into this equation to make a true statement. They're called solutions. Okay? Graphing horizontal and vertical lines. If you see this equation here, Notice it has no x in it. It just says y equals 3. Right? Looks kind of funny because there's no x. But that just means that y has to be 3. X can be whatever you want. So if I make an xy table like we've been doing for other problems, I can pick whatever I want for x. I'm going to pick all those numbers. Okay? And then y, if you look at the equation, it says y equals 3, meaning it's 3. So I pick 1. So now over negative 1, it's going to look like a horizontal line. Because you're telling me 4, that would look like a horizontal line going through negative 4. If I have y equals 0, 0 is a number, I can have this horizontal line going through y equals 0. Now, vertical lines will look like x equals numbers, because here, x equals negative 2, there's no y variable in that equation. But again, that just means it doesn't matter what y is. If I make my xy table, y is going to be random numbers, any numbers, and negative 2 is going to be all the x values. Whatever I pick, it's going to left. Okay, so back to notes on your paper, number 9. It says x equals 4. Is that going to be a vertical line or horizontal line? Vertical. Well, let's just make an xy table just to be sure that it makes sense in our heads. It says x equals 4. Then it doesn't help you. You only plot one dot on the graph, so it doesn't look like a line. Good question, though. It says x equals 4, so I'm going to put 4 all the way down, because x has to be 4. Y's can be anything I want. I'm going to pick random things this time. Okay? Plot those points. Over 4, up to 7. Over 4, 0. Over 4, negative 1. Over 4, negative 5. I could pick all of them. Whatever all the y values. Notice, what kind of line is it? Vertical, because x is 4, so that line is going through x equals 4. Look at number 10. Y equals negative 2. What do you think? Vertical or horizontal? It should be horizontal. Let's make our xy table just to make sure. Y is negative 2, meaning all of them have to be negative 2. X can be whatever I want. So I go over negative 1, negative 2, 0, negative 2, 5, negative 2. I can put all of them in there. And they're still all going to line up at negative 2, because that's what the equation says. Y is at negative 2, so my line is a straight line going through negative 2. Okay, any questions about graphing? All right, 2 more problems. Number 11 is a word problem. You're not going to solve it, you're just going to graph it. So it says that the fastest moving tectonic plates on Earth move apart at a rate of 15 centimeters per year. Scientists began studying 2 parts of these plates when they are 30 centimeters apart. So when they started, it's already 30 centimeters apart. Your graph is not going to be proportional relationship kind of looking. It's not going to go through that corner, because it's not starting at 0, 0. It's starting at 0, how many centimeters? 30. So we already know it's not going to be like that kind of graph. So they say write a linear function and then make a graph to show that movement. I already made that function for you. It's right here. Y equals 15x plus 30. And if we plugged in 0 years, it should be at 30. But let's make sure and actually do this work. 15 times 0 plus 30, what would that be? 30, right. Which makes sense because the story says that. The scientists began studying at year 0, they started now, and it's at 30 right now. Makes sense. Let's see what it is 2 years later. 15 times 2 plus 30, 60. So after 2 years, it would be a 60. How about 4 years later? Kathy? 90. 15 times 4, and then plus 30 is 90. So I'm going to graph this representation of my data here so I can visually see what's going on. So at year 0, it's at 30 centimeters. At 2 years, it's at 60 centimeters. 4 years later, it's at 90 centimeters apart.